Hello everybody, am I audible guys? Hello everybody, am I audible guys? Okay, so I think I am audible to you and visible also. There is no issue, there is no any technical fault, and I hope that you are watching me live. Please through the message let me know that you are getting my voice clearly or not. Please let me know that you are getting my voice clearly or not. So I can get your message through the Telegram. Okay, so please let me know. I hope that I am audible to you. If you face any hurdle, you can tell me. If you face any hurdle, you can tell me. And also, if you're watching on the YouTube, please leave a comment that I am audible to you. There is no problem. After that, we will start our class. So as you can see on the screen that it's lecture number 3. We have already completed the 2 lectures, and today we will discuss the lecture number 3 of classical thermodynamics. It may be possible that you guys are new on the channel, so I'll try to explain the things very quickly, whatever we discussed in the last classes, okay, but in a very quick manner. Okay. Okay everybody, so welcome back again in classical thermodynamics lecture, and you are watching me live on the YouTube as well as on our platform, and we are basically studying the classical thermodynamics. Okay, as I told you earlier that this subject is a very good subject, and you can say that very conceptual subject. Okay, so we will enjoy this subject, right? You can say that there are a lot of things which are very conceptual. There is no need to remember or mug up the things in this subject. This is the very you can say the good part of this subject, unlike the solution thermodynamics, right? Good evening Anushka, very good evening. Okay, so let me explain you that in the last lecture what we basically you can say covered. Okay, so guys, as I told you the meaning of thermodynamics in the lecture number 1, then what is the meaning of thermodynamics? In the last lecture we break this thermodynamics word in 2 parts actually. One is thermo and another is the dynamics. Okay, thermo means which is related to the temperature. Therm is a synonym of temperature actually. Okay, or you can say therm means the heat or temperature. Okay, be specifically it is related to the temperature. Dynamics means the, you can say, related to the mechanics. Related to mechanics means the things are in motion actually. Okay. So heat, what is the heat basically? If I'm saying that heat is only the mechanical energy, if I'm saying that heat is only concerned about the mechanical energy, I think no, it's not right. Heat means all form of energy. Heat we can convert it into the all forms of energy. It is not mandatory that heat is only converted into the mechanical energy. Okay. So what we discussed, the definition of thermodynamics, that thermodynamics deals with the relations between the heat and other forms of energy, like the mechanical energy, electrical energy, or chemical energy. So basically in the thermodynamics, what we have studied, guys, we studied basically the conversion between the energies, the relation between the energies actually, right? Okay. So this is basically the discussion of the first class. In the last class, we discussed some points like microscopic view and macroscopic view. Okay. So as these words suggested, microscopic means that if you are basically observe the things on molecular basis. If you are doing the study of a molecule, what is the velocity of the molecule, energy, position of molecule, like that. Macroscopic means you are studying the whole gas. Okay, you are studying the whole gas actually, right? I hope that this particular information is clear to you, right? So after that we have studied the thermodynamics properties. So guys, on the basis of that which property is independent on the mass or dependent on the mass, based on this information we can say that properties are categorized in basically two parts, right? One is your intensive, another is your extensive. One is your intensive and another is your extensive. Intensive, I connect the word intensive and independent, right? Intensive means independent on the mass, extensive means dependent on the mass, right? These are the some properties, and the direct question can be asked that what are the following properties are the intensive or extensive, right? Okay. Further we discussed about the intensive properties. What are the intensive properties? In which we have discussed the pressure term, right? Okay. This is all about the pressure, in which we basically discuss the definition and the you can say units of the pressure and the reference of the pressure. Second thing is volume, right? So what is the volume? Basically volume is my 3D space occupied by the body, and these are the units of the volume. Okay. What are the specific properties? Specific properties is basically divided by mass, means you are basically defining a property per unit mass. Okay. So if I'm talking about specific volume, it means that I am interested to calculate the volume per unit mass, right? So it can be written in 1 by rho. So what is this? It is my intensive property. Is it clear to you? Okay. So rho is equal to m by v. What is the rho? Rho is a density. Rho is a density. So volume is what? Volume is intensive or extensive? Volume is intensive or extensive? If any extensive property is divided by the mass, that property becomes the intensive property. Right? Is it clear to you? Is it clear to you guys? Now, the further property which we discussed today, that is the temperature. That is the temperature. Okay? So let's discuss the temperature. So temperature, and as you know that in the thermodynamics, temperature is a very important property. Throughout the thermodynamics we discussed about the temperature. We talked about the temperature. Okay. So what is the temperature, guys? What is the temperature, guys? See, temperature, we can say that it is the thermal potential of a body, or we can say that it is a thing which is measure the hotness and coldness of the object, right? We can say this, that it is a measure of hotness and coldness of a body, right? Is it clear to you? Am I audible, guys? Am I audible? Muhammad, Anushka, am I audible to you or not? Please let me know. Please let me know that I am audible to you or not. So temperature is what? It is my measure of hotness and coldness of a body, right? It is clear to you? Or we can say, or the second definition we can say that this is the thermal potential of the system, which is responsible for heat transfer. Okay, great. So temperature, it is a measurement of hotness and coldness of a body, or you can say it is a thermal potential of the system which is responsible for the heat transfer, right? Is it clear to you? Let's suppose a body, we have a body, let's suppose this is my body A and the temperature of this body is TA. Let's suppose this is my body B and the temperature of the body is TB. Okay, and I'm saying that the temperature of the A is equal to the temperature of the B, right? If this is true, then we can say A and B bodies are in the thermal equilibrium, right? Then we can say that A and B are in thermal equilibrium. Is it clear to you guys? Okay. We discussed about the temperature in detail. Do not worry about it. Okay. Just here we are defining first the basics of the temperature so that you can get the feel of the temperature. Right? Is it clear to you? So very simple. If I justify both the definition with the help of this example, see, let's suppose I'm saying we have a one scenario in which we are saying that TA is greater than TB. The temperature of the body A is greater than temperature of the body B. It means that the body A with respect to body B is hot. Is it clear to you? Or you can say the body B with respect to A is cold. If B is touches the A body A, then he feels the, you can say, the hotness. And similarly, or you can say simultaneously, the body A will feel the coldness. Is it clear to you? The second point we can see that it is a thermal potential, means the thermal potential of the body A is TA and the thermal potential of the body B is TB. And if there is a difference between TA and TB, if it is not equal to TA and TB, then the heat transfer between A and B is possible, right? It means if the thermal potential of body A and B is different, it means that TA is not equal to TB. In that case, we can say that heat transfer is there. Heat is transferring from A to B or B to A depending upon the temperatures. Is it clear to you? I hope that this thing is clear to you. Please let me know that this is clear to you or not. Yeah, Purnima, Muhammad, Anushka, please let me know this thing is clear to you or not. Okay. Now, see, a very basic instrument to measure the temperature is the thermometer, right? The mercury thermometer. There are different types of the devices which is used to measure the temperature, like the mercury thermometer, the thermocouple, right? So different you can say there are devices which is basically used to measure the temperature. So let me give you a basic idea how those devices works. What is the principle of those devices, that in what sense they are measuring the temperature. Okay, so please put the heading measurement of temperature. Please put the heading measurement of temperature. Is it clear to you? So guys, in the measurement we pick a property of a material and we relate that property of the material to the temperature, and we will see the variation in that particular property with respect to the temperature. Let me give an example. See, let's suppose I have an arrangement. Let's suppose I have this spring and a block is attached to it. And the mass of this block is m. Okay, right. So the basic physics, I hope that you guys are aware that this m block mass, what is the force acting on this? It is my mg in the downward, right? Gravity force is there. Due to this gravity force, this basically your spring expands some length, right? So let's suppose that this is my condition, you can say initial, and this is the stretched condition. Let's suppose this is my stretched condition, right? This is my m mass block. So this is mg is there, right? Is it clear to you? So initial position is this. This is my initial position and this is my final position of the block. Okay, it means that there is a x extension. There is an x extension in the spring. Spring is also applying a force on the mass on the block, which is basically kx, right? This is the spring force. There is no need to remember anything. There is no need to remember anything, guys, right? This is only for your understanding. Okay, so this is my mg, means due to the weight of the block, the spring extends. The spring expand, right? What is the length? This is my x length. So you can say there is a change in the length of x. Okay, so can I say this, guys? Can I say this, that see, if I increase the mass, let's suppose if I put another m mass block on this block, then can we say that this extension x will be increasing or will be increased? Yes, we can say this, right? It means that this length property, or you can say that this increment in the length is directly proportional to the mass. I hope that this is clear to you. That this increment in the spring length is directly proportional to the mass. So we basically you can say that relate this property to the mass. Likewise in the mercury thermometer, due to the heat, the mercury expands, or you can say the length of the mercury will change. So that change in the length of the mercury is directly proportional to the temperature, right? So we can say that the length of mercury is directly proportional to the temperature, right? So if temperature increases, your length of the mercury will also increases. So how we measure that? We basically connect my temperature to the one property of the mercury. One property of the mercury. I hope that this is clear to you. I hope that this is clear to you. Yes or no? Is it clear to you guys? Is it clear to you? So can we say, please यहाँ तक आप लिखिएगा and after that we will move forward. अगर यहाँ तक कुछ समझ में नहीं आया है, if you are not getting anything, you can tell me. You can tell me. That property can be anything, okay? That property can be anything. That property can be anything. Like in the mercury thermometer, this is the length of the mercury, which is directly proportional to the temperature. Okay. So please write a simple definition of the thermometer. That a device which is used to measure the temperature. A device which is used to measure the temperature, right? So the thermometer can use any property, like the you can say the resistance, electrical resistance, right? Like you have you seen the digital thermometer? That a digital thermometer basically uses the electrical resistance property to measure the temperature. Okay, in the mercury thermometer, in the conventional mercury thermometer, that length of the mercury is the property which is related to the temperature. I hope that this is clear to you. I hope that this is clear to you. So we pick a property which is related to the temperature, right? And we will see the relation between that property, that if temperature is increasing, then what is the value of that property. Now let's understand the measurement. This is my main part. Now let's understand the measurement. Now let's understand the measurement, guys. Let's suppose that we have a property X. Suppose a property X of a substance vary linearly with the temperature. Okay, so as I told you that property can be anything. Let's suppose I mark that property X, and this property X is linearly vary with the temperature. If temperature will increase, then this property will basically change linearly. So in the mathematics, can we write a linear relationship? Very easily. So we can say that X is a property and it is linearly vary. So it is A, any constant T plus B, right? This is my equation number 1. So this is the value of the property at the temperature T. Is there any hurdle in this equation? Is there any hurdle in this equation? This is the value of the property at the temperature T. This is the temperature my T, right? This is my any linear relation. I hope that this is clear to you. Please let me know. Please let me know. Any hurdle in this? Anushka, Purnima, Muhammad. Okay, don't worry. No problem. Yeah, Anushka, Purnima, please let me know. If you are not getting my point, tell me. There is no problem, right? We just start our subject. Yeah, I will explain it in an easy way. Don't worry. Yeah, what about Anushka and Purnima? See, okay, okay. See, what I'm saying, this is what I want to explain you guys. See, we have a conventional thermometer. I hope all of you used this conventional mercury thermometer, है ना? Normally हमारे घरों में मिल जाता है, right? In this mercury thermometer, the filled material is mercury, right? Filled, what is the material here? Mercury, right? And there is a scale of the temperature, right? So let's suppose if I dip this mercury thermometer in any bath, or you can say if this mercury thermometer touches any hot surface, right? Any hot surface. Okay, what will happen, guys? See, the mercury absorb the heat from this hot surface, and mercury will basically starts to expand. Everybody knows that there is a thermal expansion. What is the meaning of thermal expansion? That in the increase, due to the increasing temperature, the matters will expand generally. Is it clear to you? So mercury will gain the heat from the hot surface and it will expand. If it will expand, it means that the length of the mercury will change. So let's suppose that initial level is this, normal. At the room temperature, the length of the mercury is this. Now as it absorbs the heat, it will start to expand. So it rises, it rises, it rises, it rises, and it expands till this mark. Is it clear to you? Now this is the length of the mercury. Okay. So, and the length of the mercury is connected to the temperature. Means it is already decided that at this temperature the length must be this. Is it clear to you? So if this is the length of the mercury now, so let's suppose if this mark is of, you can say, let's suppose 35 degrees Celsius, let's suppose, and this at this mark the temperature is, let's suppose, my 39 degrees Celsius. So when the length, and let's suppose it is my 25 degrees Celsius. So when the length of the mercury is this, right? So what is this mark says? This mark says that the temperature of this hot surface is my 35 degrees Celsius. So what is that property we pick for the measurement of the temperature? Length of the mercury. Length of the mercury. We pick the length of the mercury is the property which is directly related to the temperature. According to the length of the mercury, we measure the temperature. Yes, Mohammed, I hope that this is clear to you. I hope that this is clear to you, right? In a similar way, I am saying that this is any property. This is any property which is connected to the temperature, right? We will see this. See, we cannot measure the temperature directly. Okay, temperature is nothing, or you can say that temperature is not that quantity which you measure directly. Is it clear to you? अगर आप mercury thermometer में measure भी करते हैं तो कैसे करते हैं? You just see the level of the mercury. Based on that, you comment that okay, this is the temperature, right? And that property can be anything which is related to the temperature. So the relation between the property and the temperature is the linear. What is the relation? If I am saying mathematically, then I am saying that the relation between the property and the temperature is linear. And I write the linear relation here, that this is the property at the temperature T which is varying like this. A and B are constant here. A and B are constants. Please do messages that now things are clear to you or not. Please let me know that the things are clear to you or not. Now let's understand. Just pick 2 points, guys, 2 fixed point which is very easily reproduced, or you can say which the data is basically we can get the data from the literature also. right? So for the measurement of the temperature, we should have the two fixed value, right? What is that value? Just please listen here. Listen here. Select two fixed point. Select two fixed points of temperature which can easily reproduced, right? For example, we have freezing point, or you can say ice point, right? Like ice point or freezing point. We guys are aware about the ice point or freezing point of the water, yes or no? Right? So one point is this. Another point is what? At 1 atmosphere, okay? Is it clear to you? Right? And another point is the boiling point, yes or no? Another is my steam point or boiling point. So these are these two datas we should have. So we select two fixed point. One is my ice point, another is my steam point. I hope that this is clear to you. Yes or no? Okay, let's do this calculation on the water, because it is easy to do experiment on the water. Whatever you studied in the thermodynamics about the properties, you basically take the reference of the water, because you can say know about the water. There are a lot of studies on the water. We have already the data of the water, right? So if I'm asking you, please let me know, guys. Please let me know. Tell me that what is the ice point or freezing point of the water? What is the ice or freezing point of the water? At 1 atmospheric pressure. Can you tell me? Can you tell me? Also tell me the steam point, steam or boiling point of the water at atmospheric pressure. Please tell me. 0 degrees Celsius, very good. 0 degrees Celsius. One point is fixed here, guys. One point is fixed. Another point is also fixed. That is 100 degrees Celsius. We know this, right? So there is no need to do any separate study about this. Yes or no? We know this. 0 degrees Celsius and 100 degrees Celsius. Is it clear to you? Okay. So for the ice point, can we write this equation? We have a main equation. That equation is xt is equal to at plus b, right? Is it clear to you? Yes. Good. So see, guys, please tell me guys, that at 0 degrees Celsius, when the temperature is 0 degrees Celsius, a multiplied by 0 plus b, and this is my x. What is this? This is a property, and this property can be anything. Forget about the type of the property. Okay, yes, this is any property. It may be the electrical resistance, it may be the length, it may be anything. Just we just have to remember that this is the property which is directly related to the temperature. Is it clear to you? Yeah. So this is the property at the temperature 0, right? Okay. So this part is 0. Here the constant value b is equal to x naught. So this is from boundary condition 1. Let's suppose my equation, this is boundary condition 1 and this is the boundary condition 2. So from 1 we can say my b value is equal to x naught. Yes or no? Okay. Now using the boundary condition 2, xt, a multiplied by temperature is 100 degrees Celsius plus b is equal to x, the value of the property at the temperature 100, right? Is it clear to you? We already have the value b, so we put the value of b here. What is my equation? X 100 is equal to 100a plus b. And what is the value of b? B value is x naught. Is it clear to you? So what is the value of a? A is equal to x 100 minus x naught divided by 100. So we successfully calculated the value of the constant, and this is the very you can say the basic process. Now we have to put all these constant value in the main equation to find out the real equation. Is it clear to you? Right? So I am writing here, if you are confused, what is the meaning? The value of the property, at 100 degree Celsius. What is the meaning of this? This is the value of the property at 0 degree Celsius. Yes, Purnima, Anushka and Muhammad, please let me know that you guys are done with this or not, please. Please let me know. So we have the main equation, yes or no? This is my main equation, right? And this equation is, you can say, this equation is, we can use this equation anywhere if we know the value of the constant a and b. What are the unknowns in this equation? The unknown in this equation is only a and b, right? And we calculated the value of a and b through the two boundary conditions. Now we have the value of a and now we have the value of b. We have to put all the a and b value in this main equation, and this equation is defined, right? If this equation is defined, now we can use this equation anywhere to calculate the temperature with respect to this property. This is my process. Okay. See, so we can say that put the value of a and b in main equation. Is it clear to you? So what is my main equation? This is my main equation, that x is equal to, or you can say the value of the x at any temperature T is equal to a T plus b, right? What is the value of a? X 100 minus x naught divided by 100 multiply by T plus b. B is my x naught and this is my x. Okay, what we have to calculate, we want to know the temperature. So just calculate the value of the temperature, guys, here. So it is my x 100 minus x naught divided by 100 is equal to xt minus x naught, right? Is it clear to you? And finally we can write this value, that T is equal to xt minus x naught divided by this quantity, which is x 100 minus x naught and multiply by 100. Guys, this is my main equation. Please write this equation, write all this content, and further I will explain this equation, that how we connect this equation to our concept. First, please write this. Please write this equation. With the help of an example, we will understand this equation also, right? Done? Done, guys? Yes, Purnima, Anushka, Muhammad, done? So we followed a very simple procedure where we just write the linear equation, right? After that, we, with the help of the boundary conditions, we calculated the two values A and B, put in the main equation and calculate my things. See, now this is my equation, right? Just pay attention here. Just pay attention here that one second. Okay, okay. Yeah. So just pay attention here, guys. These 2 points are fixed, x100 and x0, right? These 2 points are fixed. In this equation, this is known, this is known, this is known, because these 2 points are decided by us. We know these 2 points. 100 is also known. Okay. Only unknown things are xt and t. Xt means any property at the temperature T. So here we discuss a simple example. Okay, this is my mercury thermometer. If this is the length, then how we can say at this length, if let's suppose my initial level of the mercury is this, after absorbing heat, my mercury thermometer expands and it is up to this length. Now how we can say that if this is the length, then what is the temperature? If this is the length, then this is the temperature, right? That is decided by this equation. Put the length here, the value of the length here, and calculate the temperature. Yes or no? Again, what I'm saying that, sir, you are saying that this is my mercury thermometer, this is the initial level of the mercury thermometer, and this is the mark of 40 degrees Celsius. By absorbing heat, if mercury expands till this length, then how we can be so sure that at this length my temperature was 40 degrees Celsius? Where you build this relation? I build this relation from here. I just put the value of that property here. All the remaining things are, you can say, known, and we calculate the temperature. We calculate the corresponding temperature. So this is how we basically get the temperature related to the any property. This is the formula, which is very important formula, right? So this is, you can say, important formula. Okay. So very simple. Xt is the value of the property at the temperature T. At the temperature T, guys. Right? Okay. So just let's take a question so that it is easy to understand. Just write a question. Question is saying that length of the mercury, column at 0 degrees Celsius is 2 centimeter. Okay, and for 100 degrees Celsius it is 5 centimeter. Is it clear to you? So this is saying find the temperature when the length of mercury is 4.5 centimeter. Question is very simple. Question is already giving us the two fixed point here. What are those fixed points? That at the temperature 0 degrees Celsius, the length of the mercury at 0 degrees Celsius is my 2 centimeter. So this is the property, okay, at the temperature 0 degrees Celsius. At the temperature 100 degrees Celsius, what is the property? Means what is the length? Length is my 5 centimeter. It is already given to us. Find the temperature corresponding to the length at 4.5 centimeter. You have to just put the value in the formula. That's it. So we want to calculate the temperature is equal to means xt, means the any property minus lower fixed point divided by higher fixed point minus lower fixed point multiply by 100. I think this is the formula which we basically calculated, right? Okay, so here I'm calculating. So T is equal to xt. xt is my 4.5, means the property of the mercury at the temperature T, minus x naught. What is the x naught? 2 divided by what is the higher fixed point? 5, right? X100 means that value of the property at the 100 degrees Celsius, right? Okay, 5 minus 2 multiply by 100. Just calculate this calculation, guys, and this is your report. This is your formula. This is your answer. It is something around 83.3 degrees Celsius. I hope that this is clear to you. I hope that this is clear to you. Okay. I hope that this is clear to you. So I hope with the help of this question you got my point, that what I'm trying to say. Okay. So if I put all these concepts in a single graph, then I can make this graph that this is my any property and this is my temperature, right? When the temperature is 0, the value of the property is x naught. If it is linearly increasing, so it is my linearly increasing, right? So at the temperature, means you can say we have only 2 points now, 2 fixed point. This is my lower fixed point, this is my higher fixed point. And at the higher fixed point, if I'm talking about any, you can say water, then it is my value of the property at the 100 degrees Celsius and it is my 0 degrees Celsius, right? And we are interested to calculate that, what is the value of this temperature when the property at this temperature is my xt. This is what we basically studied here. Okay, right? Done? So we studied the definition of the temperature, right? How to measure the temperature, right? And basically what calculation involved in this measurement, we basically take into account all this matter. Okay. Now there are different types of the scales of the temperature. There are various types of the scale of the temperature, right? You heard about that we can measure the temperature, we can get the temperature value in the degrees Celsius. Maybe it can be in the Fahrenheit, maybe it can be in the Kelvin. So there are different scales of the temperature. So we should know about all that scales, right? So please put the heading various temperature scale, and this is the important thing. This is the important topic. Various temperature scale. Right, and don't worry, whatever we studied, just that is you can say if you are okay with the that previous question, then this topic is also clear to you already, right? Okay. So guys, we have the different scales of the temperature, right? And we should know how to convert a one scale into the another scale. So first we explain you can say all the scales. After that, we will try to build a relationship between the conversion between the scales, that how we convert a one scale into the another scale. After that, we will try to calculate the temperature of a faulty thermometer. Let's suppose if we have the faulty thermometer, then how we can say that this is the faulty thermometer? This is a faulty thermometer. Then how we can say that this can be the you can say the right reading for this faulty thermometer, right? Okay, just understand this. So again, for the measurement of the temperature, we should have two fixed value, means upper fixed point and lower fixed point. My upper fixed point is nothing but it is my steam point or boiling point, and my lower fixed point is nothing but it is my steam point or freezing point, right? Is it clear to you? As I already told you, and I will not repeat it again and again, that whatever we studied, we will study all the things in the context of the water. If there is any, you can say the different thing, then I will highlight that specifically we are doing the study on this matter. Okay, so again we are doing this study on the water. So we have the two fixed point. One is my upper fixed point, right? Or you can say the UFP. What is the upper fixed point? That is my steam point or boiling point. One is my lower fixed point. Lower fixed point. That is my LFP. Okay, which is what? It is my ice point or freezing point. And we know both these points in the context of the water. So we have some different scales. My first scale is degree Celsius. My first scale is degree Celsius. Right? Okay, degree Celsius. So it is my degree Celsius. What is the UFP for this? 100. And what is the UFP for this? 0 degree. I hope that this is clear to you. Another scale is my Fahrenheit. Another scale is for me is Fahrenheit. Right? What is the upper value of it? It is my 212 degree Fahrenheit, and lower point is my 32 degree Fahrenheit. Right? Okay, another is my Kelvin. Third scale is my Kelvin. Okay, third is my Kelvin. So what is my Kelvin? Kelvin up UFP is my 373.15 Kelvin, and what is it? It is my 273.15 Kelvin. This is my LFP, and this is my UFP in the Kelvin scale. Okay. Fourth one is called Reumers. Fourth one is called REUMER, denoted by capital R. Okay. Upper point of Reumers is 0 degree R, and the lowest is my 80 R. ठीक. Another is my Rankine. Okay, Rankine is my upper is 460 Rankine and lower is my 672 Rankine. Okay. Just correct this 460 672. This is 672 and what is the lowest? 460. This is my 0 and this is my 80. Okay. Done. These are the 5 scales. These are the 5 scales. Please write it and tell me. After that, I will explain it further. Okay, see. I will say the lower fixed point as LFP and the upper fixed point is UFP, right? Okay. So, a very interesting thing is that, see, what is this? We are basically, see, tell me one thing. Let's suppose a person has a fever. We have a different thermometer having the different units. One is degree Celsius, one is Fahrenheit, another is Kelvin, Reaumur, Rankine. Like, okay. So just suppose a hypothetical example. And someone has a fever. So let's suppose I'm saying generally the thermometer showing in the Fahrenheit unit. Let's suppose at the scale of Fahrenheit it is 102. So doctor is saying that this person has a fever of 102 degree Fahrenheit, right? If you are measuring that temperature for the Kelvin scale, then the reading will be different. For Reaumur, reading will be different. Rankine for reading will be different. Degree Celsius, the reading will be different. All the 5 scales showing the different readings of the temperature, but it doesn't mean that you can say that that fever is rapidly changing with respect to the thermometer. I hope this is not a possible case. Yes or no? The temperature is the fixed quantity. That temperature is the fixed quantity. This is only our scale. This is only our scale. Based on that, we are getting the different basically readings. Okay. So in any scale, one thing is constant for all the scales. What is that? Reading on any scale minus LFP. I hope you are aware about the LFP, divided by the UFP minus LFP is equal to, this thing is basically constant. This thing is basically constant for all the scale. This thing is basically constant for all the scale. Right? So this is my important thing, and this is the formula which is useful for us to calculate the relation between the scales, because this thing is common for all the 5 scales. Yes or no? Is it clear to you? Like, Let's suppose we are interested to calculate the relationship between the scales. Can I write this formula? Can I write this formula for the degree Celsius? Yes. Let's suppose it is my x, right? What is the, you can say the my common formula, x minus LFP divided by UFP minus LFP. Okay, so this is constant for all the temperature scales. If I will write this formula for the degree Celsius, then I can say C minus LFP divided by UFP minus LFP. If I will write this for the degree Fahrenheit, then F minus LFP divided by UFP minus LFP. Make sure you are writing LFP, UFP for the corresponding scales. If you are writing this formula, then LFP and UFP you will use for the Fahrenheit. If you are writing for the degree Celsius, then you will write the UFP and LFP for the degree Celsius. Okay. Similarly for the Kelvin, it is my K minus LFP divided by UFP minus LFP. Likewise in any scale यार, कोई भी scale ले लीजिए आप, R minus LFP divided by UFP minus LFP. Let's suppose I want to build a relationship between degree Celsius and Fahrenheit. Okay, let's suppose I'm interested to build the relationship between degree Celsius and Fahrenheit. Okay, between degree Celsius and Fahrenheit. Okay, so C minus LFP 0 divided by UFP is 100 minus LFP 0 is equal to, in the Fahrenheit, F minus LFP. What is the LFP for the Fahrenheit? 32 divided by, what is the UFP? 212 minus 32. Is it clear to you guys? Is it clear to you? What is it? It is my C by 100 is equal to F minus 32 divided by 212 minus 32. It is my 180. Okay, so this is your relation, guys. C is equal to, or you can say F is equal to 18 divided by 10 into C plus 32, or this is the relation you see, I think it is by 9 by 5C plus 32. This is the relation between the degree Celsius and the Fahrenheit. This is the relationship between the degree Celsius and the Fahrenheit. You can use these relation in any scale, guys, in any scale. If you want to relate the degree Celsius into the Rankine, then do. There is no problem. Use the same thing. Use the same thing. Just you should have the knowledge about the UFP and LFP for the different scales. Right? Now, how this particular thing is useful for us, just we will see through this with the help of an example. So please write it and we will solve a question. We will solve a question of the faulty thermometer. Please write it, and after that we will move further. I hope that it is clear to you. Is there any problem? Is there any problem, guys? Is there any problem? Done? Okay, yeah. Purnima, are you there, beta? Yeah, Muhammad. Okay, so let's take a very simple question first. very simple question that let's suppose I'm saying that at what temperature centigrade and Fahrenheit readings are same. Okay, I'm saying at what temperature centigrade and Fahrenheit readings are same. Okay, so if it is talking about the centigrade and Fahrenheit, so obviously we should write the relationship between the centigrade and the Fahrenheit, which is my F is equal to 9 by 5 C plus 32. If readings are same, it means the value of the F and the value of the C is same. Let's suppose it is my X. Let's suppose it is my X. Put the value here. It is my X is equal to 9 by 5X plus 32. Right, which is my you can say it is my 32 is equal to X minus 9 by 5X, or you can say it is 32 is equal to 5X minus 9X divided by 5, or I can say it is my minus 4X is equal to 32 multiplied by 5, or we can say X is equal to it is my minus 32 multiplied by 5 divided by 4. Right, what is that value? It is my minus 40. Okay, so this is the value where the value of the centigrade and Fahrenheit reading will be the same. Means F is equal to minus 40 and X is equal to minus 40 is the same thing. Okay, so this is a very simple question. This is the question actually which is I want to discuss with you, because this kind of question may ask in the GATE. Previously these type of questions is already asked in the GATE examination based upon the faulty thermometer. So just try to understand the problem. A faulty thermometer reads freezing point and boiling point of water is minus 5 degrees Celsius and 95 degrees Celsius. Yes, we know that, because we know that the freezing point is not minus 5 and boiling point is also not 95, right? So question is, what is the actual reading when it shows 60 degrees Celsius? Question is saying, what is the actual reading when this faulty thermometer is showing 60 degrees Celsius? Is it clear to you? This is my question. So see, so we are talking about a faulty thermometer. Right? And we want the right reading. By measuring the faulty thermometer. है ना? The very good thing. है ना? देखो इंजीनियरिंग कैसे काम आती है. Faulty thermometer से भी we can get the right values. In the faulty thermometer, my LFP is what, guys? It is my minus 5 degrees Celsius. What is my UFP? My UFP is my 95 degrees Celsius. This is the reading of faulty thermometer. And when the faulty thermometer reading means when it is showing the 60 degrees Celsius, then what is the right reading? This is all about the faulty thermometer. What about the actual thermometer? The actual LFP is equal to 0 degrees Celsius. The actual UFP is equal to my 100 degrees Celsius, and corresponding when it is showing 60 degrees Celsius, we want to calculate the actual reading for it. One concept is very clear, that the value of the property, or you can say the value of any scale value, how I will write it? Okay, any scale value minus LFP divided by UFP minus LFP. this thing is constant, right? So what is this value for the faulty thermometer? So faulty LFP is my, this minus is of the formula, and what is the LFP? Minus 5 degrees Celsius divided by UFP is my 95 minus LFP is my minus 5 is equal to, this reading must be equal to, this reading must be equal to the actual wala thermometer, that is minus LFP is my 0 divided by UFP is 100 minus LFP is 0. So when it is showing 60 degree, then what is the actual reading, right? So this ratio should be the same for faulty and for the faulty and for the actual thermometer. I think the very simple equation you have, you can calculate the value of T, guys. So it is my T divided by 100 is equal to, it is my 65 divided by 100. So 100 gets cancelled. What is the value here? T is my 65 degree Celsius. So when faulty thermometer is showing 60, then actual reading is basically 65 degrees Celsius. The actual reading is basically 65 degrees Celsius. So this kind of question may be asked in the GATE examination. The question may be asked for the you can say the conversion between the scales, right? So just remember this formula, and you can solve any question based on this concept. Right? Any hurdle? Any hurdle, guys? Okay. So just try to understand the more about the temperature. Okay. I will not you can say take a very deep I will not took you very deep in the discussion of temperature. We discuss only whatever is required. Okay. So see, temperature, the definition of the temperature we basically discussed in the two ways: thermal potential and the hotness and the coldness. Okay. Now just understand the another you can say point of view of the temperature. It is very clear that when we increase the temperature, the randomness of the molecules is basically also increasing. Okay, what I'm saying, just I'll only explain the one phenomena here. We will explain it in the next class. See, this is any matter. This is any matter, right? And we are giving the heat to it. Okay. So basically, what is temperature? You will understand this phenomena in the heat transfer. Let's suppose this is any device which is used to measure the temperature. What is the temperature? Basically, how this temperature is. What is basically this temperature measuring? This is basically measuring the randomness of the molecule. Okay, this is basically measuring the randomness of the molecules. All of you guys are aware about it that for a solid body, the molecules can vibrate on its mean position when it gets some thermal energy, right? That thermal energy converted into the vibrational energy, and the molecule of a particular solid body is vibrating about its mean position, right? More the heat, more is the vibration. More is the heat, more is the vibration. Means more is the randomness, right? Is it clear to you? Or you can say in any state of the matter, you can explain like this. right? Is it clear to you? Means temperature is directly related to the randomness of the molecules. Temperature is directly related to the randomness of the molecules. If you increase the heat, randomness will increase, or the measurement of the temperature will also increase. It means at the higher temperature, randomness in the molecules will be higher, right? At the higher temperature, randomness between the molecules will be higher. Because why? Because they have the more vibrational energy. Lower the temperature, lower the randomness. Lower the temperature, lower the randomness. Is it clear to you guys? Okay. Okay, let's suppose we are taking an example of a gas. This is the gas molecules, and we are giving the heat to this gas molecules. This gas molecule absorb the heat energy and it go in a random direction, right? So if we measure this randomness, we can measure the temperature. More heat, more randomness, more temperature, right? So when these molecules is basically go here and there in a random direction, with any velocity, that velocity is called root mean square velocity. That is called RMS, right? So in the next class, we conclude this RMS, or we build a relation of this RMS to the temperature. After that, we will explain the absolute zero temperature and the triple point and all that things. Okay, so this is it for the today's class, guys, right? And whatever I discussed today, please just revise it, right? Please do not think like that, okay, we do have so much time for the preparation. No, right? Just prepare in a, you can say, prepare in a way that tomorrow is your exam. Take that much of pressure if you want to hold a good rank in the GATE examination. Okay, so this is it from my side, guys. I hope you enjoyed my class and you understood all the things, but still if you have any doubt, you can ask on the group. Okay, chaliye. If you have any question, you can ask, otherwise I will leave the class. No question? Everything is clear? Everything is clear? Okay. Okay, then let's meet in the next class, guys. Okay. थैंक यू एंड रिवाइज इट. ठीक है, रिवाइज करना है. ओके, चलिए, बाय बाय एंड टेक केयर.